comparing 3 or more means. So here on the spot, we don't have 2 means, we have 3 or more. That's why we have to use Anova. So one-way analysis of variance. So analysis of variance, or Anova, is an inferential method used to test equality of 3 or more population means. So equality of 3 or more. So whenever you have 3 or more, that means you have to use Anova. So verify the requirements first. The first one, there must be k simple random samples, one from each of k populations. And depending on how many populations we have, from each one of those populations, we're gonna have one sample. So in other sections, we have 2 populations. That's why we have in 11.3, we had 2 sample sets. But here we have more than 2. So k simple random samples or randomized experiment with k treatments. Number 2, the k samples must be independent. So again, we should have independent samples values. Number 3, the populations must be normally distributed. Number 4, the populations must have the same, so this is new on this part, the same variance. 3 populations, that's why we have mu1, mu2, mu3. So suppose we are testing a hypothesis regarding k equal to 3 population means. So we have, for null, we have all these are equal to. As always, for null, we have equal to. But for alternative, we're not going to write, for example, mu1 is not equal to mu2 or is equal to mu3. We're not going to write that one. That way, we're going to write at least one. So at least one population mean is different from the others. Having this, that means we may have this one. We may have this. We may have this. So that's why I'm not going to write like this. Just write at least. So ignore that part. Write at least one population mean is different from others. As you can see here, these are different. So this is for alternative, and this is for null. Use this method Anova if the largest sample standard deviation is no more than twice the smallest sample standard deviation. So we have to find standard deviation for each one of these populations. So here it says finding standard deviations, the largest standard deviation that we have, this one should be less than or equal to 2 times smallest standard deviation. So no more than means less than or equal to. So he randomly divided 20 into 4 treatment groups. So what we have 4 groups. Group 1, we have group 2, group 3, group 4, and you can find all these 4 groups here in this table. And at the conclusion of the study, shear bone strength was measured according to ISO, so that number. And the result is here in this table. Verify the requirement to perform one-way Anova are satisfied. So requirement. Number 1, these were randomly assigned to 4 treatments. because here we have 4 groups, and for each one we have 1 treatment, so we're randomly assigned to 4 treatments. Number 2, we want to say, do we have independent? None of these are related. Meaning that these are independent. Number 3, we should have normally distributed population. And number 4, we should have, let's see, so this one, number 4, we should have same variance. So it's that one. So we have to compute standard deviations. So for this part, we have to enter all these numbers into TI-84. So L1, L2, L3, L4. You know how to find standard deviations, so I'm not going to work on that part. So I'm going to write what are the answers for each one of these groups. For the first one, here standard deviation is 2.36. For the second column, here we have 2.60. For the third one, and finally for this one, ceramic repair, here we have 2.28. Now that we have all these standard deviations, the smallest one is 2.28, and the largest is this one. Now here, our largest standard deviation, 4.22. I want to see if this is greater than or not. So this should not be greater than. So 2 times the smallest. As you can see, this largest standard deviation is not more than 2 times smallest standard deviation. So that is correct. So we do have number 4 requirement. Having this part, that means that we're gonna have requirement number 4. Okay, so those were our requirements. So in this part, we have F distribution test hypothesis regarding 3 or more means using one-way Anova. Here on this part, we can see that here is the right side cell is longer than what I have here on left. I'm not able to use negative numbers. So you have to stop here in that part. So the F distribution is not symmetric. The values of F distribution cannot be negative. That's why we have to stop here on that part. The exact shape of F distribution depends on two different degrees of freedom. So after having our requirements, step 1, as I said, depending on how many populations you have, for null, you always have equal to between population means. And for alternative, just keep in mind that you have to write at least one. So at least one population is different from the others. You always going to write this way for this section. Find alpha, then we have test statistic and p-values. I combined step 3 and step 4 because using stat test, we always are able to find the answer for test, statistic, and p-value. So these are steps. First, depending on how many populations you have to enter those into a calculator. So enter data into columns. Step 2, press stat, highlight test, Anova. And then after using this function, Anova, you have to enter these columns, L1, L2, L3, depending on how many populations you have, and then press enter. Compare p-value with alpha, state conclusion. So see now what we have here. We have 3 data sets. We don't have 1, we don't have 2, we have 3. So it's more than 2. Because of having more than 2, that means we have to use Anova. Here we have normally distributed populations. This is already given. And the information that we have are here in this table. We have small cars, medium cars, and large cars. Alpha is 5%. So to test the claim that the 3 samples come from populations with means that are all equal. So all equal, this is our alternate, and this is our null, all equal. So writing steps, step 1. Because of having 3 samples, we have mu1, mu2, mu3, and alter them. You only need to write at least one. At least one. One of the population means is different from the others. Step 2, alpha. Step 3 and 4. So I'm going to combine these two and use TI-84. So here is test statistic and p-value. Press start. Okay, we have to enter these numbers first into calculator. Start, edit, enter. L1, L2, L3. Okay, I entered all these numbers. We have 10 in each one. Press dot, highlight test. Scroll down, find Anova. And you can, it's better to scroll up because that is easier. scroll up, and here is Anova. And press enter. So you have this page. Now, because of having 3 sample size, we had 3 columns, and you should be careful what columns you used. We used L1, L2, L3, so enter these here. Press second 1, comma, second 2, comma, second 3, and close it. Press enter. And here is the answer. We have F, we have P. So I'm going to round F to 2 decimal place. The answer is 4.09, and our P value rounding to, let's round, for example, to 3 decimal places, 0.028. And we used Anova, entered L1, L2, L3. So our answer for F is 4.09, and for P value is 0.028. Step 5. Compare P value with alpha. So yes, reject. 6, conclusion. So we rejected, meaning that there is sufficient evidence to conclude. So we rejected null, meaning that we have alternative. For alternative, we have at least 1. So writing that part here. At least 1 population mean is different. From the others. For this section, excuse me, for this section, I'm not going to ask you to graph. As you can see here, we have these, but I'm not going to ask you to graph this part. So don't worry about this. I only wanted to have this here, that so this way you can see that we have different means. Community college and mathematics department has been experimenting with 4 different delivery mechanisms. Okay. So here we have 4 different methods. You can see them here on this table. We have method 1, 2, 3, 4. So one method is traditional lecture. The second is hybrid. The third one is online. And what else we have? So do their homework in lab with an instructor available for assistant. That is method 4. So the question is, do the data suggest that any method has a different mean score from the others? So this means we're trying to test if are we going to use alternative. Because our alternative here in Anova is at least 1 mean differs from the other. So that is alternative. Write the null and alternative hypothesis. It's part A. So no, I'm going to use, so this is mean, I'm going to use 1, 2, 3, 4. For the first one, that is equal to the second method, equal to the third one, equal to method 4. And alternative, you only need to write at least one differs from the others. Part B, state requirements that must be satisfied to use one-way Anova. So on this part, we only need to write the requirement. It doesn't ask us to prove. We have all these requirements here on top. It's on the first page, these 4 requirements. So each sample must be simple random sample. Number 2, we should have independent samples. So the 4 samples must be independent. So our sample is from a population that is normally distributed. And finally, we should have equal variances. So populations must have equal variances. So we have to insert all these numbers into TI-83 to find the answer to use one-way Anova. So here is our data set for this example is math delivery mechanisms. You should be able to see this and these numbers. So we have to use our test is one-way Anova. So it's that Anova one way. And we have 4 columns. So this one's easy. Just select all those 4 columns, compute. These are the answers that we have for this one. Let's use TI-8384, and you're gonna see that we have exactly the same answer. So it's 0.96 for F, and for P we have 0.4204. And enter these numbers. So we entered all these 4 columns. Now use stat. So stat again with highlight test. Scroll down to find Anova or scroll up. Enter. So I entered all these 4 into L1, L2, L3, L4. So you have to use same thing on this part. So second 1, comma, second 2, comma, second 3, comma, second 4. And close parentheses. Now enter, enter. And here's the answer for F, rounding to 2, we have 0.96. And our p-value rounding to 4 decimal places, 0.4204, exactly same as what we had on StatCrunch. This is from StatCrunch. But we did using TI-8384 because we need to know how to use calculator on exam. I'm going to write steps here. So this part is asking to test, meaning that we have to write all these 6 steps. So we already had this part in part A. I'm going to rewrite it. You can, instead of writing this way, you can write 1, 2, 3, 4. It doesn't matter. So alpha A is 5%. We did step 3 and 4. And F was 0.96. And our p-value was 0.4204. We already have the answers here, but we did using TI-84. Now, step 5. reject or not. So if was less than, you're gonna reject. If it's not less than, do not reject. So this 0.4204 is not less than 5%. So here the answer is no, meaning that do not reject. No, that's 6 right in conclusion. There is not sufficient evidence to conclude that at least one of the means for the delivery mechanisms differs from the others. Okay, here on the score we have a box plot. Again, on exam, I'm not going to ask you to draw a box plot for this section because you already know how to draw box plots. So based on what we have here on this box plot, it's asking if you support the results obtained in part C using this here in part D. So in part C, our conclusion was that we're not rejecting null. What that means, our mean are equal to not exactly same, but around the same. So based on what I have here, I can say the box plot all have around the same center. And that means we're not going to reject null. So it's not that much difference between all these four. It's approximately same. So all have around same center. That means could all have or could all be equal or near equal. And that's based on population. We have to interpret our p-value. P-value was 0.4204. So writing this in fraction, we have 4204 on top, and denominator we have 1, 2, 3, 4 zeros. So divided by 10,000. So we didn't reject null. So assuming the null hypothesis is true, we would expect this much or more variability in the 4 mechanisms, or in the 4 samples. About 4,204 out of 10,000. So out of 10,000 times, the experiment is repeated.